Okay, so let's quickly talk about the next section of our notes, which is matter and mass. So the first thing is just to go over what they are. So matter is all the stuff. So matter is anything that has mass and takes up space. But what does mass mean? So mass is the measure of the amount of matter. So mass does not change. It is how much matter is there. Okay, so matter is just the stuff and mass is the measurement of it. So when we get down to the very bottom, the very basic, the fundamental level of matter, we have these items. So this is what chemistry is talking about. We talk about the atom, the element, and compounds. So the atom is over here on the left because it is the smallest, it's the smallest unit of matter. So it's the smallest part that maintains the chemical identity of an element. So these atoms make up an element, okay? And so an element is pure. So at this point, we are still pure. So elements are just a bunch of one type of atom, okay? And then whenever you put all the elements together, you make up compounds. So we can put them in different connections and different amounts, and so we get different compounds. So compounds are no longer pure because they can be broken down into more stable substances, which is our element. So a compound is made of two or more atoms that are bonded together. And so yes, I did mention atom because if you remember, atoms are still elements. Element is just a type of atom. Okay, so we'll talk more about that in class. And so you start with atom, and then these are the smallest amounts, and then the same atoms grouped together make an element. And then these elements can be grouped together whether they're the same ones or they can be two different ones. They are grouped together and they make up our compounds. Okay, so let's talk about the properties of matter. So this is where things get a little confusing for everyone. So we're going to talk about extensive and intensive properties. So the first thing that you want to look at is the wording itself. So extensive makes you think of the exterior, and intensive makes you think of the interior. So remember that when you're thinking about what these properties are. So extensive is exterior. So this depends on the amount of matter. Okay, so this is a pretty obvious property. If you're depending on the amount, then you're talking about volume, mass, energy also can be dependent on the amount of matter. So extensive, you have to look at the outside of it and say how much is there. Okay, intensive, you're looking at the interior. So it does not depend on the amount. So this means that no matter how much we have, this property remains the same. It is dependent on the interior of this compound. So it's dependent on what the compound actually is, not how much there is. So an example of this would be like the melting point, the boiling point. So think about this, the density. Think about this for a second. If I have water, if I have a little bit of water or a lot of water, it's going to melt or boil at the exact same temperature. If it's boiling, the degree is 100 degrees Celsius. And for this large amount of water, it's still 100 degrees Celsius. So no matter how much we have, the boiling point stays the same as long as the compound stays the same, okay? So then we get into a different type of property. So now we're going to look at chemical versus physical, which is something you've talked about in your past, I'm sure. So a chemical property or a chemical change is where you are actually transforming it into a new substance, okay? So it is no longer the same thing, okay? So that is basically what we're going to talk about the entire year is types of chemical properties and chemical changes. You are undergoing a transformation into a new substance. So the ability of charcoal, which is made of carbon, to burn in air makes carbon dioxide. So if you look at this, we go from carbon to carbon dioxide. So that is creating a new substance. Another example would be magnesium. If you put magnesium in hydrochloric acid, it reacts, okay? So basically what happens is if I have this hydrochloric acid, right, which is liquid, and if I put a solid strip of magnesium in, the result is it just goes away. So this right here, this arrow, this is a chemical change. Because the magnesium doesn't just disappear, it reacts, and you have a completely new solution, okay? So that's a chemical change. We'll be discussing the chemical changes throughout the entire year. So let's look at the physical changes. So a physical change is something that does not change into a new substance. It's just changing how it appears. So types of properties would be the color, the odor, the taste, the hardness, the melting point, the boiling point, and the density. So these right here, this melting, boiling, and density, those are things that people often get confused with chemical properties or chemical changes. But think about ice. So if I take ice, which is in cubes, right? This is H2O. It's actually just solid water. If I melt it and make liquid, it's still H2O. So you see right here, I didn't change anything. All I did was melt. So this is a physical change. So we didn't create a new substance, we just changed the way it looked. So we're going to talk about the physical properties right now, and that'll be probably the last we talk about it in this entire year, is just in this unit. The rest of the year, we're going to be discussing the chemical properties. So physical change includes phase changes. Okay, I wrote this really huge because that is important. So what do I mean by phase changes? A phase change refers to when one compound changes state, such as solid, liquid, and gas. These are states, so it's the state of the compound. So when they change from like solid to liquid, that would be melting, right? This would be melting. I forgot my L. And then if I change from liquid to gas, this would be evaporating. Also boiling. There's all types of words. But anyway, so this is a physical change, okay? So let's talk about solid, liquid, and gas. So solids have definite volume. They have definite volume, and they have definite shape. So like think of the desk that you're sitting in. It has a definite volume. When you sit in it, it doesn't suddenly collapse. It has a definite shape. This is because the particles are very close together, and so they are in fixed positions. So this has to do with intermolecular forces. Basically, that just means if I have a water molecule next to a water molecule, I have a force right there that connects them. And so in solids, they're very, very close together. So I think I wrote that somewhere. I think right here. So the strong attractive forces, that's talking about this little white line, this intermolecular force. They hold the compounds very close to the other compounds. Okay, so that allows them only to vibrate. So I know I've said a lot of things. I'll discuss that more during the lecture. But basically, what I mean is that if I have here's my compounds, right? So in a solid, they are very, very close together. They're packed very tightly. So that means that they can't rotate. They can just kind of vibrate in place, all right? So let's look at a liquid. So liquids have no definite shape but they do have definite volume. So a liquid is going to just take the shape of the container, right? It's not just going to escape out the top of the container, but it will fill the container and look like the container. All right, so that it changes from solid to liquid because the particles are held close together, but they can move past one another. So basically, they're held close together, but not nearly as tight as a solid. So that allows them to move past each other, which means they can move faster. So basically, what I'm talking about here is your liquids. Your liquids, if this is so your solid was really, really close together. Your liquids may be further apart, and they could move past each other if they needed to. So that is because the attraction right here is lower because they have more heat, right? So a liquid is hotter than something that's frozen. So this attraction is a little bit further apart so that they can move past each other. So this thing, they can go around each other, but they are all held in this container. All right, so let's talk about gases. So gases do not have a definite shape or volume. So if you think about that, gases, if you open the container, they will just escape right out the top, right? That's because they do not have a definite shape nor a volume. So by the time you get to gases, you've really heated it up. So to go from solids to liquids, you have to add heat, right? And then to go from liquid to gas, you also have to add heat. When you add heat, you add kinetic energy. Kinetic energy is just movement. So down here with these solid particles, they're really, really close together. They don't have a lot of movement because they don't have a lot of heat. When we're talking about the liquid ones are further apart because they have more heat, and so they can move around a little bit. But by the time you get to the gases, if I left my container open, the gases would just escape, okay? So they have no definite volume or shape. They have the most heat, so these gas particles can just go wherever they want to go. All right, so let's look. This is the last thing about matter that we have to look at. So we're going to break it down. So we said that matter was all the stuff. And so you can break matter down into pure things, so a pure substance, or you can break it down into a mixture. So a pure substance, you can have elements that are pure. Elements are pure because they're only made of one type of thing. So if I have pure gold, that would be only gold atoms, okay? Compounds, this is what tricks people. You can have a pure compound. Not all compounds, however, are pure. So if you have a substance, if you have like pure water, okay? Pure water means that in my container, if this is a sealed off container, the only thing that's in here is H2O, nothing else. So that makes it pure because it's only one type of element over here, so it's only one element or only one compound. That makes it pure. So we get impure, and we talk about mixtures. So a mixture is just more than one type of element or compound, okay? So we have different types of mixtures. We can have a homogeneous mixture, which means it has the same composition. Basically, this means that you cannot visually make out the difference between the components. So think about salt water. If I have water, just water, that would be pure, right? But if I add salt water, this is impure. So do these look the same? I will show it to you. They look same. So just because this salt water is a mixture, this means it's a homogeneous. Can't spell today. You get it. It's a homogeneous mixture because you can't pick out the salt from the water visually. But if you think about sand water, so let me change colors. Sand in water, if you put sand in water, the sand's going to settle at the bottom, right? This is obviously a mixture. And so since you can tell the difference between the water and the sand, this makes it a heterogeneous, however you say it, mixture. So the heterogeneous mixtures, I don't think I'm saying that right. Anyways, it varies in composition. So you can visually pick out the different components. All right, that is all I'm going to go over for now. So we introduced the idea of matter. We talked about matter, what it was. We went through the fundamental building blocks, which was the atom, the element, and then we went all the way to compounds. We talked about extensive and intensive. Extensive depends on the amount. Intensive does not depend on the amount. Chemical versus physical. Chemical, you're creating a new substance, and physical, you are not creating a new substance. So physical includes phase changes. So phase changes, it's when you go from one compound to another. So this going from one to the other, that is a phase change. We talked about solid, liquids, and gases and what makes them different. And then we broke down either pure or mixture. Those are our different types of matter.